Hi everybody. Today's lesson is 5-6, least common multiple. We had talked just recently about adding and subtracting fractions that are like fractions or fractions that have like denominators. Well, this lesson is going to be a step on the path towards what happens when we try to add or subtract fractions that don't have like denominators. Well, we need to make them like denominators, and the reason or the method by which we're going to go about doing that is finding the lowest common denominator, and to do that we need to learn about the least common multiple. So let's go ahead and do that. We'll start here. A multiple of a number is a product of that number and a whole number. And sometimes numbers have the same multiples, and these are called common multiples. Okay, so these are concepts that you may already know. Let's look at two numbers. Let's look at the multiples of 4 and the multiples of 6. The multiples are 4. 4 times 0 is 0. 4 times 1 is 4. Times 2 is 8. Times 3 is 12. 16, 20, 24, 28, 32, 36. These are multiples of 4 by taking 4 and multiplying it by a whole number. Here are the multiples of 6. 6 times 0 is 0. 6 times 1 is 6. 6 times 2 is 12. 18, 24, 30, 36, 42, 48, 54, and so on. So notice these are the multiples of 4. These are the multiples of 6. Let's see if we can find some multiples that are in common. Well, 0 is a common multiple. What else? 12 is a common multiple. Any others? 24 is a common multiple. Others? 36 is a common multiple. Okay, so these are multiples, 0, 12, 24, 36, that 4 and 6 both have in common. However, the least of the non-zero, so the ones that aren't 0, common multiples, is called the least common multiple, okay, or the lowest common multiple, the LCM. So the LCM of 4 and 6, the lowest common multiple, the least common multiple of 4 and 6 is, right, 12. So the LCM of 4 and 6 is 12. Well, is there a way to do this? Because sometimes if we're talking about big numbers, or if we're talking about algebraic expressions that aren't just numbers, is there a way of doing this without actually listing out all of the multiples? And just like finding the greatest common factor, the lowest common multiples can be found in a different way also, including the prime factorizations. If we were asked to find the LCM of 108 and 240, well, I don't really want to go out and list the multiples of 108 and then list multiples of 240 until I find the lowest, the least non-zero multiple that they have in common. So there's another way to do that, and it comes from finding the prime factorization. So what we're going to do first is we're going to factor. And we're going to factor using exponential form. Exponential form. Okay, and that's where we're going to bring together. If we have 3 multiples of 2, we're going to write it as 2 cubed. Then we're going to, whoops, number 2 is after number 1. We're going to line up the factors. And then from there, we can find the least common multiple by taking the greatest number of factors from each, and I'm going to say each column, and you'll see why I say that in a minute, column, and multiply. Okay, so after you've written this down, we'll do an example. Alright, let's see if I can move this a little bit. And the first thing we're going to do is we're going to find the factors. We're going to find the prime factorization of 108. So 108, what does that equal? Well, it's 2 times 2 times 3 times 3 times 3. Okay, I did that off to the side. So off to the side here, let's see if I can move this. I did 108 equals 2 times 54. And 2 is prime. 54 is 2 times 27. 2 is prime. 27 is 3 times 9. 9 is 3 times 3. So my prime factorization of 108 is 2 times 2, so 2 factors of 2 times 3 times 3 times 3 are 3 factors of 3. So 108 is 2 factors of 2 times 3 factors of 3. Now I'm going to do the same thing to 240. 240 is, and I'll let you do this work off on the side on your own. 240 is 4 factors of 2, because you've done this on your own off on the side, times 1 factor of 3 times 1 factor of 5. So these are the prime factorizations. Let me move this sheet a little bit. Okay, the prime factorizations of 108 and 240. So there's step 1 done. Okay, step 2 is to line up the factors. We've done that. So there are my factors of 2, there are my factors of 3, there are my factors of 5. Notice 108 does not have a factor of 5 in it. What I'm going to do next is I'm going to say, I'll draw a line here, and the LCM, the lowest common multiple, is equal to the product of the highest number of each factor found in these two numbers. So there's factors of 2 in both of them. What's the highest number of factors of 2? This has 2 2's multiplied together. This has 4 2's multiplied together. So the highest number of 2's multiplied together is 4, right? This has 3 3's multiplied together. There's only one of them, so there's 1 3 multiplied together, if that makes sense. So what is the highest number of factors of 3? 3 of them. This has 0 5's multiplied. This has 1 5 multiplied. So what's the highest number of 5's being multiplied? 5. So to find my lowest common multiple, I just perform this operation. So this is taking the greatest number of factors from each column, if I line them up properly, and then multiply. So when I do this calculation, I end up with 2 to the 4th, 2 times 2 times 2 times 2 times 3 3's multiplied together, 3 times 3 times 3 times 5, and I get 2,160. So see, I don't want to have to find all these multiples of 108, then all the multiples of 240, until I find, hey, finally 2160 matches up. Okay, that's a little bit too much work. This is going to take some getting used to. Okay, I realize it's not exactly obvious. So we're going to do a couple of examples just to make sure you've got it. Okay, so you can maybe want to have your 3 steps beside you while we do a couple more examples. All right, this example might be a little less complicated, but it might show you the steps a little better. Find the LCM of 6 and 12. So the first thing I'm going to do is I'm going to find the prime factorization of 6 and the prime factorization of 12, and I'm going to line up the factors and then find my LCM. So what are the factors of 6? Well, 6 is 2 times 3. 12, well, 12 is 4 times 3. 4 is 2 times 2, and then times 3. So it is 2 factors of 2 times 1 factor of 3. So to find the LCM, since I've lined up my factors, there are my factors of 2, there's my factors of 3, and I line them up, and this is 1 factor of 2, 1 factor of 3, 1 factor of 3. So my LCM is the product of, and I look and I take the highest number of factors from each column. This has 1 factor of 2, this has 2 factors of 2, so my highest number is 2 factors of 2. This has 1 factor of 3, this has 1 factor of 3, so my highest number of factors of 3 is 3. And then I do this calculation. 2 times 2 is 4, times 3 is 12. So it turns out the lowest common multiple of 6 and 12 is 12. Now this is the case where I could write out the multiples of 6 are 0, 6, 12, 18, and so on. The multiples of 12 are 0, 12, 24, and so on. So hey, look, there's 0. Well, I can't count 0 as the lowest common multiple. It's the first one that's not 0. And there's 12. So in this case, yeah, you could find the multiples. But remember, the previous example was much more difficult to do that. So this technique is one that we want to rely on. Let's try one more example like this. So this example asks us to find the LCM of 9, 12, and 15. So I'm finding the lowest common multiple of 3 things. Again, I could list out all the multiples of 9, all the multiples of 12, all the multiples of 15. Well, I couldn't really list all of them, of course, because there's an infinite number, and I certainly don't want to do that. But I could try and list them out until I found the lowest one that is common, that is not 0. But the more efficient way to do it is to find the prime factorization of each one of these, line up the factors, and my lowest common multiple, least common multiple, same thing, will be equal to the product of the highest number of factors from each one. So when I factor 9, I get 3 times 3, which is 3 squared, or 2 3's multiplied together. Notice I left a column here because I know that I could have a prime factorization where there is a 2 involved. So I don't want to put my 3 here, so I want to try and line up my factors. And in fact, when I get to 12, I notice that there is 2 times 2 times 3. So there is a factor, two factors of 2, because it's 4 times 3. So I'll multiply 2 times 2 times 3, and now my 3's are lined up, my 2's are lined up here. 15 is 3 times 5, so I'm going to line up my factors of 3, and a factor of 5 I'll put out here in the 5 where I would put 5's. Now my least common multiple is the highest number of factors from each column if I line them up properly. This has 0 factors of 2, this has 2 factors of 2, this has 0 factors of 2, so my highest number of factors of 2 is 2 of them. This has 2 factors of 3, this has 1 factor of 3, this has 1 factor of 3, so my highest number of factors of 3 is 2 of them. This has no factors of 5, 12 has no factors of 5, 15 has 1 factor of 5, so the highest number of factors of 5 is 1 of them. So then I take this and I have 4 times 9 times 5, and I get 180. Okay, not so bad. Just take some practice, take some getting used to. Ooh, here's one that's way different. No, it's not. Haha. Remember, the hardest part about algebra? Recognizing what it is you're looking at. If you're finding the LCM, you have 3 steps to follow. And those steps will always get you where you need to be. So just because these look different than just the numbers we were looking at before does not mean you do it any differently. If I want to find the LCM of 18xy squared and 10y, I'm going to find the prime factorization of 18xy squared and the prime factorization of 10y. And my LCM is going to be the product of the highest number of factors in each column if I line them up properly. So what is 18 times x times y squared if I break it down into its factors? Well, 18 is 2 times 9, which is 2 times 3 squared times x times, and there are my factors of y. There are 2 of them multiplied together, so I'll leave it in exponential form and say y squared. Okay, now what about 10y? Well, 10 is 2 times 5. Now I'm going to cram 5 in here because I don't want it to fall under the 3 and I don't want it to fall under the x, times y, and I'll put that there. So now that I've lined up my factors, again, the same rules apply. I take the highest number of factors from each of these. This has 1 factor of 2. This has 1 factor of 2. So the highest number of factors of 2 is 1 factor of 2. This has 2 factors of 3. This has no factors of 3. So the highest number of factors of 3 is 2 of them. This has 0 factors of 5. This has 1 factor of 5. So my highest number of factors of 5 is 1 of them. Similarly, 1 factor of x, no factors of x, so my highest is 1 factor of x. This has 2 factors of y, this has 1 factor of y, so my highest number of factors of y is 2, and then I can go ahead and I can carry out that calculation. And when I do that, I get 90x y squared. All right, not so bad. Let's do one more thing, and it'll sort of springboard us into what happens when we add or try and add and subtract fractions that don't have common denominators. A definition: the least common denominator, the lowest common denominator, LCD, of 2 or more fractions is the LCM, the least common multiple, of the denominators. So if we were asked to find the LCD, the lowest common denominator, of 5/9 and 11/21, what do you think we do? That's right, we need to first find the LCD of, we'll call it the LCM, because the LCD is the lowest common multiple of, and I just look at the denominators, 9 and 21. So the LCD of 5/9 and 11/21 is the lowest common multiple of 9 and 21. So when I go back, I just follow my process. 9 is 3 times 3. 21 is 3 times 7. So I take the highest number from each. So that would be 3 squared times 7. So the lowest common multiple is 9 times 7, which is 63. So that means the LCD of 5/9 and 11/21 is 63. So the lowest common denominator of 9ths and 21sts is 63rds. Last example before I cut you loose. Find the LCD, the lowest common denominator, of 5 over 12b squared and 3 over 8ab. So remember, the LCD equals the LCM of the denominators, denoms. Okay, so to find the lowest common denominator, I find the lowest common multiple of the denominators. So to do that, I find the factorization of 12b squared and the factorization of 8ab, and the LCM, which is equal to what we're looking for, the LCD, is going to be the product of the highest number of factors that show up. So 12 factored is 4, whoops, I keep doing that, 2 to the 4th times 3, and 2 factors of b multiplied together. 8 is 2 times 2, which is 4 times another 2, so that's 3 factors of 2 times a times b. So I take the highest number of factors from each. This has 2 factors of 2, this has 3 factors of 2, so the most is 3 factors of 2, 1 factor of 3, and no factors of 3, so the highest is 1 factor of 3, no factors of a, 1 factor of a, so the highest number of factors of a is 1, 1 factor b, 1 factor b, the highest is 1. So my lowest common multiple of these two denominators, which makes it by definition the lowest common denominator, is 24. Oh, I'm sorry, made a way big mistake back here. This should be a b squared. That should be a b squared. Sorry, don't yell at me, don't yell at me. 24ab squared. See, this has 2 factors of 2 because I forgot to carry it over there. Some of you already caught that already. Please don't send me emails, hate mail. Oh, I don't want to cry. I'm very sad when I cry. Okay, so the lowest common denominator of 5 over 12b squared and 3 over 8ab is the lowest common multiple of 12b squared and 8ab, which is 24ab squared. So the lowest common denominator of these two things is 24ab squared. Okay, I'm going to cut you loose. Make sure you get lots of practice on this because it's easy once you get the hang of it, but you just have to make sure you get enough practice until it becomes pretty easy for you. All right, see you next time.